Ingestion of plastic occurs more frequently than entanglement. However, entanglement is more frequently reported. Here are some images of examples of entanglement. Microorganisms are microscopic organisms that can only be seen under a microscope, including bacteria, fungi, and protists. Specialist bacteria seem to have been eating the plastic garbage we throw into the ocean. Some debate on whether they're cleaning up our poisons or just passing them back up the food chain. The ocean contains vast amounts of plastic, mostly tiny shards or microtrash, floating just beneath the surface.
Similar microbes have been seen ingesting plastic in landfills. The first evidence of marine bacteria breaking down the plastic in the ocean was discovered just a little bit ago. Plastics that they have been ingesting contain toxins
such as phthalates and other persistent organic chemicals found in the ocean. In a recent study, out of 852 items found,
microplastic, which is any plastic that's less than 1 millimeter in length, accounted for 65% of debris, and mainly consisted of denser plastics such as PVC, polyester, or polyamide. Microplastics are typically more dense than macroplastics, and in some places that number was as high as 80% of the plastic found.
Recent research on plankton eating and pelagic fish in the North Pacific Gyre has indicated that 35% had ingested plastic, averaging about 2.1 pieces per fish. However, Davison and Ash in 2011 found only 9.2% of sampled mesopelagic fish, those that inhabit water at depths from about 200 meters to 1,000 meters, contain plastic in the North Pacific Gyre.
Here's how microplastics actually affect the organisms when they're ingested. Microplastics are translocated from the gut into the circulatory system within 3 days of ingestion, and then they persist in circulation of the blood for over 48 days. The research also found a higher number of smaller particles, which are nanoparticles, in the circulatory fluid than larger particles, which indicates that these smaller particles have greater potential for accumulation in tissues of organisms. There is little doubt within the scientific community whether or not the weathering of this plastic can produce nanoparticles. These nanoparticles can easily be absorbed by phytoplankton and zooplankton. Another potential secondary source of degradation into microplastic is through the digestion of wildlife, which transport plastic waste up the food chain. Also, this plastic waste can be transported from one location to another because animals migrate during the seasons. Plastic and microplastics is a huge issue in regards to the food chain, especially because if, say, a plankton were to eat a microplastic and then be eaten by a krill, and then the krill is eaten by a whale, that all is working its way up the food chain. But the most concerning thing is that these plankton can be eaten by fish that we will later eat. As humans, we are extremely conscious of what we put in our body, but the issue with plastics is that we are unaware that it is going into our body, and not only the plastics are going into our body, but also the toxins that come with the plastics.
Here's what you can do. This one plastic water bottle can break down into 1,000 microplastics. By just conserving this one plastic water bottle, you can be saving marine mammals of the food chain and even us humans. If everyone in this class conserved just one plastic water bottle a day, think of what we can do for this marine environment and even us ourselves.